Welcome to Manual Wheelchairs, Optimizing Prescription and Setup, presented by Sheila Sherman. This clinical education webinar was originally delivered as part of a live global series written and presented by a team of clinicians from all over the world. My name is Angie Kiger, and I'm currently the Clinical Strategy and Education Manager at Sunrise Medical US. Throughout this webinar, you will be hearing my voice, because I served as the moderator for this series. We appreciate you choosing to watch this recorded on-demand version of the webinar. With all of that said, on behalf of Sunrise Medical's Education and Motion team, here's Sheila.
Thanks, Angie. Hello and welcome to today's webinar. You're watching a version that is recorded specifically for online purposes. When this webinar was originally offered live, it was recorded. However, the quality of the audio was not what we felt would be appropriate for putting online for viewers to watch after the fact. So I'm re-recording it today for you. Now, hopefully by viewing today's webinar, you will, at the end of the webinar, be able to accurately describe at least 5 factors that influence rolling resistance in a manual wheelchair. You'll be able to compare and contrast different casters, tires, and rear wheel choices with respect to rolling resistance, as well as be able to accurately describe the implications of wheelchair configuration and setup for 3 methods of independent propulsion. And those methods of independent propulsion are hand propulsion, foot propulsion, and hand and foot propulsion. In terms of content disclosure, all of the webinars in our global live series were developed collaboratively by the Sunrise Medical clinical educators. So we are all full-time employees of Sunrise Medical. But by no means do we mean for these webinars, or for this webinar in particular, to promote any product, any model of product or brand or manufacturer. Now, in terms of a little bit about me, so as Angie said, my name is Sheila Sherman. The GH is silent, so it is pronounced Sheila. I'm an occupational therapist. I'm registered with the College of Occupational Therapists of Ontario, and Ontario is a province in Canada. So I've been an occupational therapist for over 25 years. And as a clinical occupational therapist, I've worked in a number of different facilities, including a rehabilitation hospital and in a number of different units there, including neurological rehabilitation, as well as complex continuing care. And I've also worked in community rehabilitation, where I saw clients with various diagnoses living in their own environments. Now, I am coming to you from just slightly north of Toronto, so that would be about there on our map of the globe, if you're watching where my cursor is. So I'm not going to give you a long, detailed introduction about me, because I'd like to spend the time talking about manual mobility. At the very end of today's webinar, you will see my contact information if you do have any questions for me. Now, because this is a global webinar series, I thought that I would start with a global resource. So the World Health Organization published their guidelines for the provision of manual wheelchairs in less resourced settings. And for those of you who are viewing this webinar who live in wealthy countries, you still might feel as though the particular area where you live and work is perhaps less resourced, in the sense that you're not able to provide everything in terms of manual mobility that you would like for your client through the funding source. And then, of course, there will be others of you who do live in less resourced settings. What the World Health Organization said for those of us in less resourced settings is that we really need to consider a number of different factors when we're optimizing wheelchair prescription. So those factors are things like stability, and stability is comprised of a number of different components. So we're thinking about both static stability as an individual sitting in a wheelchair, as well as dynamic stability when that individual is propelling the wheelchair or performing movement in the wheelchair. We can think about rearward and forward stability And I'll be talking a little bit more about that in the webinar. But essentially what that's looking at is the tippiness of the wheelchair in either a forward direction or in a rearward direction. And lastly, there's also lateral stability. So that side-to-side stability that we also have to think about and the implications for function for clients. We can also think about maneuverability, and that's something else that we really should be considering. So whether we're thinking about how that wheelchair maneuvers in different environments, in a small cramped environment, or whether the client is participating in a sport, for example, and needs to have greater maneuverability. We're thinking about the pushing efficiency or the rolling resistance of that wheelchair, and I'll spend some time talking a little bit more about that. We should also be thinking about the ability to transfer, particularly for those clients who are independent in their transfers. So how will the wheelchair prescription enhance that independence with transfers? What about the ability to transport the wheelchair? We need to think about whether the client is going to be remaining seated in that wheelchair in transit, so whether it's a private vehicle or a public vehicle. And if that's the case, we need to think about the crash worthiness of that wheelchair. Or is the client going to be lifting the wheelchair into the vehicle, or an attendant or caregiver lifting the wheelchair into a vehicle? That might also be something that we're factoring in. And then, of course, reliability. The World Health Organization says that we should be thinking about that, particularly for clients that do live in, say, rural settings where there isn't a service shop down the road to help out if there's any issues. And with that as well, we need to think about the availability of components. So if a repair is needed down the road, that the wheelchair can be repaired successfully for the individual. So we're going to start by thinking about our perhaps high school physics. And you might remember Newton's first law of motion. And what he said was that a body at rest tends to stay at rest, while a body in motion tends to stay in motion unless it's acted upon by an external force. So when we think about this, we're thinking about inertia and rolling resistance. And so inertia is the tendency of an object to resist change in motion. And for an individual in a wheelchair, we have to overcome that inertia in order to initiate that propulsion, so to start the movement of the wheelchair. There will always be more force that's required to initiate that propulsion, to overcome that inertia, than there is to maintain a constant set speed or pace by the individual. But in order to maintain a constant pace or constant speed, an individual has to overcome rolling resistance. And so that's what we're going to talk about next. Rolling resistance is the force that resists a motion when an object rolls on a surface. So what this means is that it's going to limit the distance that a manual wheelchair can coast after a push stroke or after force is applied to the wheelchair. Now, there are a number of different factors that impact rolling resistance. And so we're going to talk about each of them. The first one is the mass or the weight of the individual user. As therapists, that's beyond our scope of practice, but it is something to bear in mind. Obviously, a heavier weight individual will have a higher rolling resistance, all things being equal, compared to a lighter weight individual. Something else that influences rolling resistance is the mass or weight of the seating system combined with the weight of the wheelchair. Now, this isn't going to be the only thing that influences rolling resistance, but it is one of the factors. The weight distribution between the front casters and the rear wheels is another factor that influences rolling resistance. So we're going to talk a little bit more about that as we go on in in the presentation. And the size and the type of the casters and wheels also influences rolling resistance. Again, I have more information on that. The surface that the wheelchair rolls on will also influence rolling resistance. So if I'm rolling over a low pile carpeting, that will have greater rolling resistance than rolling over tile or hardwood flooring, for example. And maintenance of the wheelchair also will have an impact on the ability of that wheelchair to roll. If there's a lot of hair or debris, for example, in the caster, that's going to slow down the coasting of the wheelchair. If there is toe in the wheelchair, in the past we called this toe in or toe out. So if there's toe in the wheelchair, that again will also impact the rolling resistance of the wheelchair. So when we're thinking about minimizing rolling resistance, we want to achieve this because that's what's going to help us in terms of efficient propulsion. So it's going to make it more efficient no matter which method of independent propulsion there is. So whether it's hand propulsion, foot propulsion, or a combination of hand and foot propulsion, we need to think about minimizing rolling resistance. Even for the assistant or attendant who is pushing a manual wheelchair, if that wheelchair has been set up optimally to minimize rolling resistance, it'll make it easier for somebody else to push that wheelchair with the occupant in it. And then for an individual who foot propels or hand and foot propels, we can also help to prevent one of the causes of sliding for individuals that propel with that method. And what I mean by this is that because we have to overcome inertia when we are starting that movement of the wheelchair, if we're using our foot to initiate that propulsion, if I have to overcome the rolling resistance in the wheelchair, I might have to really dig on my heel and pull forward to get that wheelchair to start moving. And by using this sort of motion and trying to overcome the force of the wheelchair, that might cause the pelvis to slide forward, and that can contribute to sliding. Of course, there are other reasons why individuals slide from their wheelchairs, but that would be the topic of another webinar. Now let's first think about our choices in manual wheelchair selection. This is going to be one of the first things that we will be thinking about, and then we'll be thinking about how to configure this manual wheelchair. Now I know, across my country, across Canada, and across the world, we're all going to categorize manual wheelchairs differently. So let's think generically. There are essentially 3 different categories of manual wheelchairs that we can think about for those who are independently propelling the wheelchair. We can think about a standard wheelchair, a custom folding or ultralight wheelchair, or a custom rigid wheelchair, which is also considered an ultralight wheelchair. In a standard wheelchair, we have some ability to achieve some positioning. So perhaps the arm supports may change height, the foot supports we can adjust, and the back posts in some models also have some adjustability. That is to achieve positioning for the client in the wheelchair. In a standard wheelchair, what we have in terms of the rear wheel is essentially only the ability for vertical rear wheel adjustment. So changing the height of the rear wheel relative to the frame. What this allows me to do if I'm adjusting the vertical rear wheel position is that this is going to adjust the seat to floor height for the client. This can also change the seat angle or the seat slope. So if my front seat to floor height is higher than my rear seat to floor height, I'm introducing some seat slope. This can have the benefit of using gravity to assist with positioning, and many of us will know using gravity to assist in this way. Our vertical rear wheel adjustment will also affect transfers. It'll affect foot propulsion. So getting that rear wheel at the optimal height is going to be important, and also access to the environment, getting under tables or desks, for example. Now, hopefully what you also see in the graphics below are that not only do we achieve perhaps better positioning using gravity to assist, but we also can achieve some more optimal rear wheel access through the upper extremities. So here in the picture to the left, we've got some shoulder extension while trying to reach the hand rim. But on the right, what we're seeing is that there's the less need for such great extension of the shoulder, and it's a more optimal positioning of the upper extremity. Now, I apologize if you've seen these graphics in the past. They have been with Sunrise Medical for a number of years, so throughout the globe, you may have seen these. But I still think that they are a good resource and a good reference for us to think about because they really do highlight the points that I'm trying to make. So that vertical rear wheel adjustment will affect some function for a client in terms of when we're looking at seat to floor height. It will affect the seat slope, but as well, let's not forget that it can also affect access to that rear wheel, to the hand rim. Now, when we're thinking about the vertical position of the rear wheel, we need to think about wheel access. So if my wheels are too low for a client, or if they are too small, what can happen is that that individual is really reaching down far to access that hand rim. And so because of this, because the height is not optimal relative to the frame of the wheelchair, then these wheels are further from the individual, from the user. And so they have less access to that hand rim. They're not going to get the same biomechanical advantage when propelling with their hand or with their hand and foot. And so we can have more strain going through the upper extremities. So this is an important thing to think about, not necessarily because of rolling resistance aspects, but because we have to think more broadly and we're thinking about protecting the upper extremities from any potential issues. So like I said, this is something to think about, whether we are hand propelling bilaterally or hand and foot propelling. In terms of my vertical position, another thing that can happen is that the wheels might be too large for an individual, or the seat to floor height might be too low relative to the size of the rear wheels. And so what happens in this case, what you're seeing from the graphic, is that the shoulders are really elevated when trying to access the hand rim. And so again, with this, we also run the risk of injury because of some impingement that could be happening in the shoulders. So again, this is something that we think about whenever the hand has to be on the hand rim. So whether an individual propels by hand or by hand and foot, this is something that this placement of the vertical position of the wheel we need to think about. So again, this is what we can achieve and think about when we're looking at standard wheelchairs. And then of course, as we look at the other categories, we can also look at this. But looking at the standard wheelchair, this is the adjustment that we get, really just essentially the vertical position. When we move to the custom folding wheelchair, now we're moving to a category of wheelchair, as I said, which is considered ultra lightweight. And the frames themselves are much lighter in weight than the standard wheelchair. In addition, we have a lot more options when we're looking at the rear wheels, when we're looking at the tires, when we're looking at the hand rims, all of these factors that go into an order form. In fact, there can be so many choices that you might have an order form that's 10 pages long because you can really custom configure the wheelchair to the needs of the individual client. Now, all of our configurations of the wheelchair, all of our choices that go into speccing out a wheelchair, that's going to have an influence and impact on the rolling resistance. So later on, we're going to talk about some of the choices that we can be making with our clients and how that could have a potential impact on rolling resistance. Now, when we move to custom folding wheelchairs, now we have more adjustability in the rear wheel. So not only that vertical adjustability, but also horizontal adjustability for center of gravity. We have some lateral adjustability, as well as the ability to add in some camber to the rear wheel. And I'll talk a little bit more about each of these. Now, when I'm talking about custom folding and custom rigid, I realize that what I'm talking about is perhaps ideals. And I'm not going to get into funding and what people qualify for in the different parts of the world. I'm talking about in an ideal configuration for reducing rolling resistance and looking at some other factors for clients. In a custom rigid wheelchair, now we are also looking at a wheelchair that is lighter in weight than the custom folding wheelchair. And part of the reason is because there's fewer moving parts on this wheelchair, and the components could be lighter in weight, as well as the design of the wheelchair. So in a custom rigid wheelchair, we do not have a folding cross brace. It doesn't mean that these wheelchairs can't fold down. Sometimes the back canes or back posts can fold down onto the seat. But I don't have that cross brace. I do have a camber tube that goes across. This chair, again, there's different models, so you can have something that is fully welded for an individual, or you can have some adjustability in terms of the setup of the chair, whether it's the center of gravity. We might have some adjustability there. So because there are fewer moving parts, because there's no cross brace, these chairs are more efficient to propel than a custom folding wheelchair or than a standard wheelchair. And so what this means is that more of the energy of propulsion that is directed to the hand rims goes in moving that chair in a forward direction. So I'm not losing some energy through any flex that's occurring. Now, the other benefit of a custom rigid wheelchair is that because I have fewer moving parts, these chairs tend to be more durable. So I don't have, swing in, swing out foot supports that might need some adjustment over time. So with the custom folding and the custom rigid wheelchairs, I do now have that ability for that horizontal rear wheel adjustment. So what that means is that relative to the frame of the wheelchair, my wheels could perhaps be in a rearward position. This is what you're going to find in those standard wheelchairs. Or my wheels could be moved into a more forward position, which is what I could see when I'm working with a custom folding or a custom rigid wheelchair. If I'm using a wheelchair where my rear wheels are in a more rearward position, or if I have a custom folding wheelchair where an adjustment hasn't been made yet to the rear wheel, those rear wheels are in a more rearward position. So the person's center of gravity, which is roughly at the level of the belly button in a seated position for a number of people, then what happens is my center of gravity is more forward. And so I'm actually putting more loading through those front casters. And I'm not putting enough loading through those rear wheels. So what happens with this, because of that weight distribution, I'm getting more or increased rolling resistance. Because this chair has more rolling resistance, it's going to be much more challenging, more difficult for me to overcome that inertia, as well as to continue with the pushing forward, so that pushing efficiency. So my rolling resistance is going to be increased in this way. Now, one of the benefits of having my rear wheels in a more rearward position is that I'm introducing a lot of rearward stability to the wheelchair. And what that means is that my wheelchair is less likely to tip in a rearward direction. Now, of course, wheelchairs can have anti-tippers, which also helps to prevent tipping. But this is just the physics of this wheelchair when the wheels are in a more rearward position. Now, the opposite is going to occur, though. So if I have a lot of rearward stability, less likely to tip rearwards, what that means is that I actually have a little bit more likelihood of tipping in a forward direction if my center of mass goes beyond my base of support. And so when we're thinking about a wheelchair, our base of support, typically speaking, is our front casters and our rear wheels. we might have some anti-tippers. But what's touching the ground for our base of support is the casters and the rear wheels. And whenever my center of gravity goes beyond my base of support in any direction, that's when I introduce some tippiness, some instability to the wheelchair. So if my rear wheels are in a more rearward position and I have more anterior instability, what that means is that if I'm going to reach for something off the ground in a forward way, if I move my center of gravity too far forward, I can have some tippiness. Or if I have my center of gravity more forward, if I have a large abdominal mass, if I have lower extremity lymphedema, I'm loading those front casters even more and having even more instability in the front of the wheelchair. Now, what we also notice from this picture is that when my rear wheels are in a more rearward direction, I have less access to my hand rim. So I'm able to access it, but it means that I have to excessively extend my arm to be able to reach that hand rim. So I'm going to have a less efficient stroke and again, running that risk of repetitive strain injury. So as I said, this is typically speaking how your standard wheelchairs are set up, that the axle of that standard wheel is close to the rear of the frame. There are some models that do have, say for example, a 1-inch offset in the rear wheel for that center of gravity, so it's a little bit more forward, but it may or may not be sufficient for your particular client. Now I can also have my rear wheels in a more forward position, so that the rear wheels are forward relative to the frame of the wheelchair. What this does is to take some of the load off of the front casters and more of the individual's weight or load over those rear wheels. Now, many of you will know that we're trying to achieve 20 to 30% of the load over the front casters and 70 to 80% of the person's load over those rear wheels. When we have that sort of weight distribution, that's going to help to decrease the rolling resistance in the manual wheelchair. Now, one of the factors of this, or one of the outcomes of this, is that we're going to introduce more forward stability in the wheelchair. So the chair is less likely to tip in a forward direction, but we are introducing some rearward instability. So an individual might experience or feel some tippiness at the back of the wheelchair. So this isn't necessarily a bad thing. So there are anti-tippers for these wheelchairs, but as well, some of our clients might want the ability to pop a wheelie, to go over a curb, or to go over soft ground, for example. So we need to think about the function of our clients. Now, what we're also seeing in terms of rear wheel access when we're looking at the position of the upper extremity is that when the rear wheel is in a more forward direction, I can have a more neutral position of the shoulders, the elbows, the wrists on that hand rim. And that's what you're seeing in this graphic. So when I'm looking at optimal rear wheel position, what I'd like to try to do is to be able to reach 1/3 to 1/2 behind the rear wheel, 1/3 to 1/2 in front. And ideally, I should be able to have my elbows at about 100 to 120 degrees of flexion when the hand is at the very top of the hand rim. So a little bit more forward there, but at the very top of the hand rim. Now, there's other evidence that talks about optimal rear wheel position. Some of you, if we go back a slide, might also know about having your middle finger or the tip of your middle finger reaching the center of the axle when the hands are in a relaxed position. Now, evidence also says that the optimal rear wheel position should be that the axle, the rear wheel, is moved as far forward as possible without compromising the stability of the individual. So we're looking at both forward and rearward stability and without interfering with the caster size. Because if my rear wheel is too large and my caster size is large and I try to have that rear wheel as far forward as possible, some of my choices might be limited or I might have some interference with that front caster. And then again, Some of the evidence is saying that perhaps what we should do with our clients, because of that instability that we have when that rear wheel is moved forward, is that perhaps that should be done incrementally so that that person becomes accustomed to the tippiness in the rear of the chair. Now, another thing that we're able to do with the rear wheels when we're looking at the custom folding or the custom rigid wheelchairs is we can look at the lateral wheel position. And so this is achieved by a camber tube or washers to look at the spacing that's occurring there. Why we want to think about this is because this does affect the upper extremity position to the hand rim. It will also affect our overall width of the wheelchair. And this will have that impact on lateral stability. So when I have a wider wheelchair, I'm going to experience some lateral stability because I have a wider base of support, particularly if the individual center of gravity is up high relative to the seat to floor height for that wheelchair. Now, also by having this ability to sleeve the wheels in or out, it's also helping me to perhaps take a little bit more camber in the rear wheels. And what I mean by camber is that slant or that slope in the rear wheels. When I have more camber, that's going to help in terms of the lateral stability of the wheelchair. So if I'm reaching to the side, that wheelchair is not going to necessarily tip over to the side. Camber can also help in terms of efficiency of turns. Now, in a basketball wheelchair or a tennis wheelchair, you're going to have significant camber because that's going to be required to be able to function and play those sports in those sorts of wheelchairs. But in an everyday wheelchair, perhaps you have 2 or 3 degrees of camber, and that's going to help in terms of some of the maneuverability. It can also help in terms of wheel access, being able to have my hands positioned effectively at the top of the hand rim. Now, one of the things I do need to take into account is accessibility issues. So if I do have camber on the rear wheel, as well as I'm looking at the overall width and the lateral spacing of the wheels, I need to think about, can the client still get through standard doorways? Or looking at their home environment and looking at the width of the doors. Now, there are always going to be lots of choices in terms of configuration when you're able to customize a wheelchair. So looking at a custom rigid wheelchair or looking at a custom folding wheelchair. And so some of the choices are things like your casters, your forks, your stem bolts even, your different lower leg assemblies, different frame choices, different hand rim choices, even the seat slope and how the wheelchair is set up. So lots of ways that these chairs can be configured. When we're thinking about caster wheels, we can think about the different choices there. So when you look on an order form or look at a manufacturer's website, you'll see some of the choices include things like micro-lighted, which are very popular with the pediatric population. But this is a very hard material, and we'll see later that it actually has a beneficial effect on rolling resistance. You've got your standard polyurethane. This is sort of your typical that would be in a standard wheelchair. You've got a pneumatic, so it's an air-filled or semi-pneumatic, where it's meant to act like an air-filled in terms of having that smoother ride and reduced vibrations, but it's more of a solid fill so that no risk of flats. You've got aluminum soft roll, so these are designed to provide a nice smooth ride for an individual. So lots of choices in terms of caster wheels. So there was a study done that compared caster wheels. And in this study, they looked at caster wheels of similar size, but what they were looking at is the material. So they looked at casters that were your standard caster. They looked at the soft roll as looking at a roller caster, so something that's somewhat like that micro-lighted, but that hard material. And what they found is that your standard caster, which is often on those standard wheelchairs, has the most rolling resistance. The soft roll was sort of in the middle. And your roller caster, so that harder material, had the least rolling resistance. This, of course, would explain why, when a basketball wheelchair is configured, that's why we're seeing these roller casters, because they're going to have the least rolling resistance on a smooth surface. Now, when we look at rear wheels, we're going to talk about the diameter and how the larger diameter of the rear wheel decreases rolling resistance. There was a study done that looked at the size of the front caster, and that's its effect on rolling resistance. So they compared casters that were 4 inches, 5 inches, and 6 inches. And what they found was that what made the biggest, most significant effect on rolling resistance was not the size of the caster, but the weight distribution between the front caster and the rear wheel. So whenever you got to more than 30% of the loading going through the front caster, that's when the size really didn't have a significant effect. So it was that weight distribution that had more impact for reducing rolling resistance. Now, another thing that we can look at when we're thinking about weight distribution is the caster stem housing position. And so I don't mean the position of the caster, but more this stem housing. So bringing my cursor over. So in this picture, this caster housing or this journal housing is in a more forward position relative to the frame of the wheelchair. And in this picture to the right, this caster housing or stem housing is rearward relative to the frame of the wheelchair. And this can also affect the weight distribution. Sometimes it's not enough to just adjust the rear wheel, center of gravity. Sometimes we also have to think about this caster stem housing and how that can influence the weight distribution. Now, this isn't available on all models of wheelchairs, but for those models that have it, it's a nice thing to think about to enhance that redistribution of load. So when my caster stem housing is in a more forward or leading position, this is going to reduce the loading that goes through those front casters. So it's taking some of the weight off those front casters and redirecting it to the rear wheels. What this means, though, is that I also have a longer wheelbase. So I'm thinking about that when I'm thinking about maneuverability in environments. When my caster stem housing is in a rearward or trailing position, then I may be taking some of the load, more load through those front casters, but I do decrease the overall wheelbase of my wheelchair. So it's a tighter fit in some different environments. Now in some models, say for example, rigid wheelchairs, we also have the ability to select where that caster housing position might be. And so we want to think about the effect on stability of the wheelchair and also the functional implications. So if I'm looking at this graphic, I can have some choices, position 1, 2, and 3, for example. And what that means is that when my caster housing is in a more forward position, it's more forward and it's more lateral. And if you remember what I was talking about, base of support, so what this means is that I'm going to have more stability in a forward direction because I have a wider base of support and it is more forward. Now, that can have some functional implications, which means that it could be more difficult for me to get into tight spaces. It could be more challenging for me to get close to the toilet for a toilet transfer, for example. Whereas position 3, I would have some greater maneuverability in environments in that I'm able to get in tighter to locations. But I am taking more of the weight through those front casters. So if I'm configuring a wheelchair like this, I need to think about that weight distribution between what's going to happen with the front casters and with the rear wheels. Now, sometimes a compromise is the best solution. And so I might want to select something like position 2, where I'm getting the benefits of that additional forward and lateral stability in the wheelchair. That's going to help me if I want to reach forward to lift something off the ground, for example. But it's also going to allow me to get in tighter to locations where there's something solid on the ground and I'm trying to move my wheelchair in closer. So different things to think about. So it's not always just about rolling resistance. Now, when I'm configuring a custom folding or a custom rigid wheelchair, I also have choices in terms of my rear wheels. So there's mag choices, and even within mags, there's selections. I can have a 5-spoke or a 6-spoke, and my choice will have a difference in weight of upwards of a pound, uh, whether because the 6-spoke will be higher weight than the 5-spoke. When I'm looking at spokes, I'm going to have more choices there as well, a light spoke, an ultralight spoke. And there's also a manufacturer that makes Spinergy wheels. So Spinergies are available on many manufacturers' wheelchairs. And we'll talk about some of those differences, why we might think about one over another. When I'm comparing the wheel types, many of you are going to be familiar with the mag wheels. These are a popular choice because there's no maintenance involved with these. However, they're going to be the least performance-based. When I'm looking at the wheels, there will be some flex in a mag wheel. So it means that it's not going to be as rigid, and when we talked about rigidity, that's what enhances that propulsion. I also have spokes as a choice. Spokes got a bad name about 20 or so years ago, but they do need less maintenance than they have in the past. There is some maintenance to make sure that the spokes are tight and in place, but there's less flex in the spokes. So again, I'm enhancing my efficiency of propulsion. Now, the Spinergies often are an additional cost that many funders may not cover. But the reason why these are selected is because they are the most efficient in terms of being the lightest weight. They're the most rigid, so there's less flex here. Now, what you might see at the bottom is when I talk about trueness. And if I'm looking at a mag, what that means is any wavering that you might see. So if I took a mag wheel and I'm holding it in my hand and I spin it around, what I'm going to see is a little bit of wavering occurring. And that's because it's an extruded plastic. So that little bit of wavering or lack of trueness that I'm seeing is going to reduce the efficiency of propulsion, whereas spokes and Spinergies are more true. So I'm going to see less of that wavering. So the spokes and Spinergies are going to offer greater efficiency for an individual propelling their wheelchair, and it's just a matter of questioning, is it an appropriate fit for the client given that some maintenance may be required. I also have choices in terms of rear tires. So we need to think about the type and the size of the tire that is being prescribed for an individual. As I said earlier, a larger diameter tire will have lower rolling resistance. And so this is going to affect the seat to floor height and rear wheel access for a client. What's also been found, and which many of you will already know, is that the pneumatic tires have been shown to have less rolling resistance than a solid tire or an airless insert. Now, the reason why sometimes people don't select a pneumatic tire is because they are concerned about the risk of flats for individuals. There are many different models of pneumatic tires. There's even a model that has a Kevlar sleeve or Kevlar lining within it to help prevent punctures from occurring. So there are many different choices. Now, many people don't prescribe pneumatic tires because there's the concern that with some deflation, you're going to increase the rolling resistance. There was a study done, it was several years ago, but what they did find is that there was no statistically significant difference in the rolling resistance of pneumatic tires until you reached about 50% deflation of the recommended value. So that's a significant amount before there was this statistical significance occurring. In another study that was done, it was found that maintenance of about once a month was sufficient to maintain the air inflation of pneumatic tires. So not a significant amount of time required for the maintenance of the pneumatics. Tire tread also makes a difference. So you can have a smooth tread that's going to have least rolling resistance on a smooth, flat surface. That's why if you go to an airport and you see these transport wheelchairs, they'll have no tread on that rear tire because that wheelchair is being used in an indoor environment. Now, knobby tire is going to have the most rolling resistance, but it's going to be an appropriate choice for an individual who's using their chair in soft ground, in rugged terrain, to have that grasp in the different environments. Now, we've talked a little bit about the factors when we're configuring a wheelchair and making things optimal for a client based on the evidence. But we also have to balance the functional factors with what will enhance propulsion for a client. Now, another thing we also have to think about is how is the client propelling the wheelchair? And sometimes clients require a little bit of education. Now, I'm not going to talk about all of the different wheelchair skills to go through, but at least looking at hand propulsion, looking at the biomechanics for that. So there is some evidence that we should be providing some education to our clients. And what was found when an analysis of different stroke types was done was that really we want to encourage clients to use a long, smooth stroke that's really going to limit any high impact on the hand rim. And when an individual is propelling using their hands or a hand and a foot, then we want to make sure that the client has a recovery phase. So rather than clients who we might see in long-term care facilities where they're lifting their hands up before they bring them back down on the hand rim, what we want to encourage for all of our clients is to have that recovery phase where after the release of the hand rim, that shoulder and the shoulder relaxes, the hand comes down for that recovery phase as there is that release from the wheel. And that's going to help in terms of minimizing risk in terms of repetitive strain injury. So let's sort of put all of this together. We're coming towards the end of the webinar. If we're thinking about hand and foot propulsion, we need to think about balancing the factors that affect rolling resistance with the factors that affect rear wheel access. So we need to think about those upper extremities for the client. We need to ensure that we're looking at an optimal seat to floor height, nothing too high or too low for the individual client. And for that individual that does hand and foot propel, we want to make sure that if the client does have two lower extremities, that we are supporting both thighs with the seating if we do have one foot on a lower leg assembly or on a hanger or foot support. For individuals that foot propel, we need to balance the factors that affect rolling resistance with other functional needs. We need to think about the method of propulsion for that individual client. And this is going to affect the seat to floor height that we are selecting. So does the client use that typical heel strike and pull through? If that's the case, the measurement that we're looking at is from the popliteal fossa to the heel of the foot with the client wearing the normal shoe that they would typically wear when they are foot propelling. But there are some clients that don't use that gait pattern. There are some clients that shuffle along with their feet, that they don't have much plantar flexion or dorsiflexion and have very limited ability to lift their feet. If an individual is using this shuffling pattern, we still take the measurement the same way that we did for that individual that uses that heel strike and pull through. But here we will use some clinical judgment, and we may be adding 1/4 of an inch to that measurement just so that there's enough of a gap so that that client's foot doesn't get stuck as they're trying to shuffle their feet along. And then we have some clients that have significant plantar flexion. So again, that measurement from the popliteal fossa to the back of the undersurface of the heel of the shoe may not necessarily help us. We need to take that as a starting point, but then also look at how much additional height do we need for that plantar flexion. So we're taking the measurement from the popliteal fossa to the point of the ball of the foot, for example, of the forefoot, where the client is making contact. And then depending on how much of a significant difference there is, we may be adding half an inch to that measurement so that there is that clearance for that individual. So the method of foot propulsion, the gait the person uses, is going to be critical for us in determining the appropriate seat to floor height for that client. And then final thoughts as we're wrapping up this webinar. Rolling resistance is clearly not the only consideration that we think about when prescribing a manual wheelchair, but it is helpful for us to be mindful of this when we are configuring a wheelchair. If we're in an optimal, ideal world and we have the availability to make choices for our clients or with our clients at the outset. So we want to think about the functional performance in the various environments that the individual will be taking their wheelchair and using their wheelchair. We need to think about stability of that wheelchair versus maneuverability and the impacts on the different choices that we make. And then we also, of course, have to include the client and we are considering with them the factors that are important to them. So there are a number of different references that help me with today's webinar, and they'll be in the handouts. And I do want to thank you for listening to this recorded version of the webinar. My information is on there. If you do want to reach out and if you have any questions, just let me know that you viewed the webinar and then you have some follow-up questions and I'd be happy to answer them or help you direct you to the clinical educator in your country. So thank you so much for listening to this recorded version of the webinar. I hope it helped to meet your learning needs and that you're able to gain some insights to help you when you're working with your clients. Thanks for watching. Take care, everybody. Bye for now.
Well, that wraps up this webinar. If you would like to access more valuable clinical resources such as this webinar, I encourage you to visit the Education in Motion portal found on the Sunrise Medical website for even more valuable information, such as additional webinars, printable resources, blogs, links to various industry websites and white pages, user case stories, and much more. Once again, thank you for watching, and if you have any questions or comments, do not hesitate to contact us at eim@sunmed.com.